Hi guys, in this video I'll go over the ArrayList class. I start out by explaining the concept and then I'll go over an example. Now let's start by reviewing arrays. An array is the most basic data structure that can store multiple elements in a consecutive memory location. We can create an array specifying the element type, square brackets, an identifier, the new operator, and then the element type followed by the length of the array. And the length in square brackets here specifies the capacity or the total number of elements that can be stored in the array. So here it's 5, so it can store 5 integers. Each of the elements are initialized to the default value of that type. So the default value for integers are zeros. Now let's add a couple of elements to that array. At index 0, I store 5, and at index 1, I store 7. So this array will now hold 5, 7, and the remaining elements are still 0. Now, whenever I add an element, I have to keep track of the index. So here I specify index 0, then I specify index 1, and if I were to add another element, I have to keep track and specify the next available index, which would be 2. So there are some limitations. And one limitation I just mentioned is we have to manage the indices. We have to manage the index for the array. There are more limitations. Let's say we keep adding elements to an array. Eventually we'll hit the capacity. We hit the length of the array, so everything will be stored. We have no more room available to store additional elements. And we cannot resize the array. So an array is of fixed size. And that means we have to predict the size when we create it, right? If I don't know how many elements will be stored in the array, I probably make this large enough to predict the worst case, the most elements that could possibly come up. But yet at the same time, I don't want to create it too big. Let's say we create an array of 1,000 elements and we end up just needing 20. We waste a lot of memory because here we have memory reserved for 5 integers, but if we added only 2, 3 of them is just wasted memory. So we don't want to make an array too large, but we also don't want to make it too small that we end up not being able to store additional elements. Because of these limitations, we have the array list. So we can create an array list, also specifying the element type after the class name here. So in this case, it will be integer. So for an array list, we can only store object types. So for any of the primitive types, we have to use the wrapper type. The wrapper type for an int is the integer. I call this list, and I call the constructor array list with integers. And then I'll import this. It's in the java.util package. And note that the initialization I can simplify. I don't have to specify the element type as second type. So I can just use the diamond operator here, and the element size will be inferred. Now here, internally, this array list will also have an array. By default, the size of the array, the internal array, will be 10. If I want to have a different size initially, I can specify that in the constructor. So if I specify size 5 here, this will give the capacity of 5, but the size of 0. Note that you almost never need to specify the capacity. You can always just use the default constructor and everything's perfectly fine. An initial capacity of 10 is really appropriate for almost all situations. But here I set it to 5 to keep it consistent with my array that is also 5. So we have two terms, capacity and size. Size reflects the number of elements that we have explicitly added to the array list. Capacity is the current capacity that the array list can store, or the current number of elements of the internal array. Now let's add the two elements that I added to the array up here. So 5 and 7. So I do list.add, I add 5, list.add, and I add 7. Immediately you notice I don't need to keep track and manage the index. I simply say I want to add 5 to it and I want to add 7 to it. And now I have the same what I have up here. I have an array that stores 5 and 7. Yet I never managed the index. It is done internally by the ArrayList class. Now let's add a few more elements. Let's say I add 9, I add 3, and I add 4. And then I'll output the list that I have. So the nice thing here that this is a class, and this class overrides the toString method. And so simply passing the ArrayList object to the println method will nicely output what's stored in the list. So here you can see it stores 5, 7, 9, 3, and 4. 5, 7, 9, 3, and 4. And the size at this point is also 5. So the capacity will be 5 and the size is 5. Now what happens if I call list.add and I add another element? Let's say 1. Now internally it will check that capacity matches the size. It will create a new array. So here a new array, but not with 5 elements, but now twice the capacity that it had before. So in this case, it will be capacity of 10. After it creates the new array, it will copy the elements from the old array. So 5, 7, 9, 3, and 4. Then it will no longer need the old array, so it references the new array. Capacity is now 10, size is 5, and now it has space to store the next element, which is 1. So it stores 1, and size is now 6. And now I can keep adding new elements. If I were to hit the capacity again, it will then create a new array of twice the capacity, so of 20. Copy the elements over, and then it has a capacity of 20. If I reach it again, it will be 40, 80, 160, and so on. So each time I hit the capacity, it will create a new array twice of the size. And note that everything is hidden underneath this add method. I don't have to manage it. It's all managed by the ArrayList object. So if I output this again, and I run this, we can see it now stores 1 in the ArrayList as well. So I potentially have unlimited space that I can add, and I don't have to predict it. Initially, I just make it just large enough for what I need, and 10 is really good by default. So I don't have to manage the index, I don't have a fixed size, I don't have to predict the size. Let's see how we can iterate over the ArrayList. We can use a for loop with an index I less than list.size. So the size method will give me the number of elements in the ArrayList. Size is similar like length for strings, for example. That gives me the number of characters, or the length property of an array. Now that I know the size and I iterate over it with the index here, I can output each element. I do print. So each element I output in square brackets. Then I call the get method by index. So get at index I. Initially this will be 0, right? It will output 5, will increment I by 1, and then call get at index 1. It will output 7, and so on. I put a closing square bracket. And now running this will output each element in a square bracket. So we can see it down here. Now after that, I add a line break. And then there's a second way I can iterate over this. I can iterate over it using the for each loop. So for every value in my list, I want to output it. And actually, instead of outputting it, let's say we would just want to sum it up. We can say total, initially 0, and we add each value to the total. And then I output the total. So here we see the total is 29. So what I just demonstrated, we can use the index-based for loop, and we can use the for each for loop. Now, I went over the add method, the size method, and the get method. There's also a remove method. So we can remove an element at a specific index. Let's say we want to remove the element at index 1. At index 1 we have 7. So what will be the output if we output the array list again? Now running this, it will output 5, 9, 3, 4, and 1. What happens when we remove an element at the given index? It will copy subsequent elements over by 1 position. So 9, copy 1 before, 3 it would put here, 4, 1 over, and 1 over. So basically it moves all subsequent elements 1 to the left, so that there are no gaps. Whenever we remove an element, it will always copy them over. Now there's another remove method, list.remove. This is the object, so we can specify any value we want to remove. And this will remove the very first element that it finds. So let's say we want to remove 3 here. We cannot use 3 because this would be the index, and currently it's a bit confusing because I store integers. So we have to create a new integer object. So I do integer value of, and then value of 3. This will create an integer object, so wrapper object. And then when I output this again and run this again, I can now see it removed the integer value. And this was stored at index 2. So there's a remove method, remove by index, and remove an object that it finds. And that's pretty much it for an array list. So remember that an array list, you don't have to add anything. You don't have to specify the capacity when you create it. It will automatically grow for you, manage all the indices underneath. We don't have to keep track of it when we move elements, when we add elements. Note that it never shrinks in capacity, so it only double. The reason for this is when it grows, there's more likely that you need that capacity later again in your program. So it doesn't shrink, it only grows. I hope you enjoyed this video. Thank you for watching.